Cheers.
Yeah, thanks for that. Thanks for reminding. Yeah, so that's why we've chosen a mutable list here. Yeah, because it will grow, we know.
Okay.
Yeah. Any questions?
Yeah, it was when it did puzzle me a little bit
Mm,
when we were
mm.
in the for each. It
Yeah.
was just then when it had to break it down from the
Mm,
property text.
mm.
So that lambda, yeah, that lambda right there.
Yeah. Yeah.
So it basically broke it down and put it each
Mm.
property text into that property.
Correct. Yes. Correct. Exactly. So here we are calling another.
And that's where the call for the second factory method.
Correct. Yes. Yeah.
Okay.
Yeah.
Yeah. All right. Yeah. That's the bit that like was a little bit foggy. I didn't
Yeah.
know what was happening, but yeah, I understand it now. That's where the call is for the
Yeah.
second one.
Yeah. It's a bit, see, but because we've nested them, that's why it has come a bit like, oh, what's going on?
Nesting.
I mean, it's just nesting.
Yeah.
But that's what the abstract factory for, because we can call other factory methods inside the factory method.
Mhm.
So, yeah, yeah. I was a bit forcing there as well because of to get that into the head is a bit like, I mean, spinning. I
Yeah.
mean, yeah. So, but then, yeah, that's how you can iterate through and create stuff and add it to a list to hold on to that and pass it into this to create this. Yeah. So yeah, maybe we can try an example, another exercise or something. I mean, which you can try by yourself, or you can you know start with this and do it by yourself and see how you see it.
Yeah. Yeah.
Yeah,
Definitely.
yeah, definitely, man. That will let you practice a bit with the lists and for iterating through and things like that, creating a list and things like that. Which will
Mhm.
definitely you know uh, let you feel it a bit more. Yeah,
Yeah, I was looking at some of the some of
mm.
the lessons you had before, and
Yeah.
there was a good lesson, and I was just trying to get through. I was just trying to have a look through that because
Mm.
I didn't have any contact with making lists and stuff like that.
Ah, yes. This will come always in Kotlin. I mean, any yeah, and as an Android developer, I can say you can always create lists. No applications is out there with no lists.
Right.
Every application you pick will have a list. For
Okay.
example, let's have a WhatsApp. Where's the list here? Can you see a list here?
The list of users on the left.
Exactly. You see. So every single mobile app will always have a list.
Yeah.
Always, there will be a list. So yeah, 99% of the time we will be dealing with lists in
Yeah.
a mobile application. So
Okay.
it's good to get our hands dirty a bit, with the
Yeah.
lists.
So you have to know. Yeah. Get familiar
Yeah,
with making lists.
correct. Yeah, I was thinking, rather than having a name value here, I could probably choose a map itself. You know,
Okay.
yeah, I can simply say because a map itself is um, um, name value
Key
pair,
value
right?
pair.
Yeah, key value pairs. Exactly, that's the name for it. Correct. Excellent.
Mhm.
Yeah. So I can say map of something, or properties or something, property map or something, right? And it will be in this case the map of string key and the values will be string. Yeah.
Mhm.
So yeah. So I can. How do I do this? So property will take a map of. Yeah. There you go. Map of name value. Ah. Oh, sorry. Found string. This is a string. Uh, oh yeah. Oh yeah, map of name to value. Yeah, because the map of takes a pair like this.
Okay.
Yeah, don't go too much into it. I mean, why that and this? I have learned Kotlin first just to read it, and then writing will become natural. You see?
Okay.
Yeah. If I need to ever create a map of, I give a name to value because that's how I'm mapping it.
Mm-hmm.
Yeah, that's it. That's all we need to know. That's how we can just write the map. So property
Mm-hmm.
map of now. Yeah, so we haven't changed anything, but we just changed the data type to a map, which is more
Yeah.
simple in this case, Then I don't need to
Okay.
create it with the name separate and value separate. I can just join it with a map because the map is, as you said, key value pair.
Mm-hmm.
So this should work as well. Yeah, done. So it's see property map is, yeah, that's the map. Key to value pair.
Mm-hmm.
Yeah, done. Okay. Um, right. So that's the abstract factory. So we've done that's all factory methods there, all the factories. We've covered all the factories. Jared, any questions? Do you want anything add to this or any questions?
No, actually.
Have you used a factory? Any of these design patterns before? You would have.
Uh,
I mean, did you know that you were using one of these?
yeah, I study, but I couldn't
Ah,
apply deep like that.
ah, yeah. Okay. Right, no problem. Yeah, I mean, now you know it as well, so anytime you see code like this, you know what they're using and what's the underlying idea,
Yeah, yeah.
Cool. Right. So shall we go to the next one or you want to stop here, guys? What do you think?
Yeah, we can have another go of the builder. That'd be
Oh,
nice.
brilliant. Yeah, builder is small, simple. Right. So builder, right? So these are all, so as we're studying, these are all creational patterns, right? So we want to create objects in a way they suit our problem, right? So we've seen factory where that will suit us. So if you want to create similar kind of objects, yeah, choose one of the factories depending on the purpose. Yeah. Or singleton if you want to create the same object throughout the whole application. Now let's come to a builder. Yeah, builder is easy. Builder is so simple, but the thing is the builder comes in place whenever you have an object with a lot of properties, right? Say 100 properties inside them. So you have something called, say, user. User could have a first name, last name, age, address, his profession, and where did he study before, a lot of information, right? So this user has, say, that 100 properties inside it. How do we create this object? So every time when I create this object, I'll need to pass in all these 100 variables into properties inside it, right? So it'll become a hassle when we create these big objects. Yeah. So that's where we use a builder pattern to build things, build a complex objects easily. So let's have a look at, how that looks in Java, because I've seen this there, and that looked a good example. Again, this was a user, I think, to create. And in Kotlin, the task of creating a builder pattern becomes much, much easier as well. So in Java, yeah, see, the builder pattern, as the name implies, is an alternative way to construct complex objects. Complex objects in this sense, what does it mean? If it has a lot of properties, yeah, it's complex. It's considered as a complex object. This pattern should be used when we want to build different mutable objects using the same object building process. Yeah, so the building of this object process is going to be the same, but we want to create different instances. Different objects. Yeah. Understand it? What's the problem, guys?
To build, yeah. So
Yeah.
I've seen it before.
Ah,
Like I'm doing Jetpack Compose at the moment, and everywhere you go, it's
yeah.
got a modifier, and it's got a dot.
Yes.
Something of
Good, 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 good. Good that you're bringing in the exact places you're seeing these design patterns. Yes, that's the builder pattern with those, the compose uses, dot modifier, dot width, and dot color, and this and that. It's
yeah.
really building an object, yeah, with a lot of properties using a builder pattern.
I wouldn't know. It's only because it's
Hmm.
there,
Yeah.
but for me to create it myself,
Hmm.
yeah. But I've seen it, but yeah, I don't know the ins and outs of it.
No problem. Yeah, but they are using a builder pattern as well. So yeah, okay. So what is a complex object in this sense? What do we mean by it's a complex object? Because of it has
Many properties.
Correct. Yeah. So it'll become a hassle, right? A nightmare to create these, right? Every time the process, if the process is the same. Yeah. So yeah. So like, I mean, this they're doing, right? So they have a user object, say first name, last name, age, phone, address. This is the user class. And yeah, you see, they are yeah, so they want to create these objects like that, but then this is the build. Oh yeah, so they want to create it like this. Yeah, so they want to create a user with a first name, last name, age, and phone, and then they want to create another user with first name, last name, phone, and address. And here they want to build, they want to create a user with only that, and here only just with these names. How do we do this? See, the process is the same to create the same user object always, but passing in different combination of values or properties, or all of them, yeah. So how do we do that? So the builder pattern in Java would be looking like this. So they will first, have all of the properties defined. If there are 100, they have to define all of them, and then they will have all the setters, and the static class builder will take stuff in and pass the same object out so that it can continue building the thing on top of the the properties you pass in. Yeah, so when you call it, you will call it like this: user builder, just with these two names. Yeah. Oh no, sorry. In this example, they've created it to always pass in the user with the first name and last name, right? It's a must, because as you can see, this user class takes, where have they defined that? But it takes all of them, but then where is that? They're showing user builder, maybe user name builder. Ah, yeah, there. User builder. If you call this builder class, that needs to start with the first name and username, right here. So that's why when they call the user builder, they have to pass these two first, and then they can pass the rest of them optionally, and then they call the last build method to put everything together. Yeah, this build. This is the builder pattern in Java. But see how much is going on here? A lot of code, right? See, and also nearly missed that. I mean, where do we make it how do you say, mandatory, that to call this to always pass with the first name, last name? See, every time I build a user, I would always have to have a first name, last name. That's not optional here. The optional ones are the rest of them. These, I could either create user with these, but definitely with the user first name, last name, or these in this case. So here, this the second user, but with no address. First user with nothing, but yeah, of course, with the mandatory fields. Yeah. So how do we do this? This is the builder pattern in Java, right? So how do we do this in Kotlin? Kotlin is one line, man. Not by this, because if you see, the builder pattern is always going to have all this defined, getters and a builder class like these, and making something optional or mandatory. That is all that. Sorry, no setters, because yeah, if you want, you can have the setters too to access them. But the way they return the thing which is built is by this. So you pass in age, you set the age, set it internally, and you return the same object so that they can continuously do dot on it. So you pass age, you set the age, and return the same object. You then can call dot phone on the same object so that it can repeat itself, to repeat to build the same object with the the things you're passing in here, right? But the thing is, right, in order to create this builder pattern, all this code is going to repeat for another one. Say that there's another one, I mean, not the user, but say a building or something, school or something, or office or something. The builder pattern is going to exactly look the same. Yeah, all that's repeating of code. Remember, we saw the singleton in Java was kind of a bit of boilerplate, right? So we just called it with the object, and that brings in all what you have to do by yourself in Java in one line. So similar thing here, and we have seen that already. the builder pattern can be achieved with the data class. So this is the builder pattern for us in Kotlin. No, not builder, user. So I'm creating a user. So I want the first name and the last name, age. These are strings, of course. String, of course, and then age. It's an in. What else? Address or something. No? This will be string and carrier, so on, right? Yeah, but then right. So according to what they have done, they have created the first user with all of these, right? How do we do that in Kotlin? So I want to create first user with everything. User one will be equal to user. So I need to pass in all these, right? Jason. Jason, what's your second name, Jason?
Yeah, Calvert, Calvert.
Okay.
Yeah.
T.
T at the end, yeah.
Ah, okay.
That's right. Calvert.
Age, I don't know. How
I'm 50.
50, yeah. Half century, right?
Yeah. Well, I'm 49, I'm 50 in Feb.
Next February.
Yeah.
Oh, yeah, 50. So 49 plus then.
Yeah, I'm 49 now, but I just call it 50 because it's very close.
Yeah. Wait, isn't it? Yeah, same thing. I'm doing that as well, sometimes. I'm 44, but but when I was 43, I was saying I'm 44,
Yeah.
Yeah. So some address, right? Some address, right?
Mm.
This is an integer. Okay.
Yeah.
Right. Second user, I want to create it with some optional ones. So I want these, but here they're creating it with an agent form. That's all they're creating it with. How do we do that? I want only the names, but no address or no phone. They also have the phone here, right? It's okay. Yeah. Phone. Yeah. Phone before that. So it's a phone number, right? But here they only want these, not the rest of them. We can achieve that too in Kotlin. So data class with named arguments and default parameter. So yeah, so you can default this to something. Yeah, default this to something. Default this to, because of these being the optional. You can default them, and then you can achieve this. So then you don't need to pass the optional ones always. Here, the first name and last name should be given. Otherwise, it's a problem because we didn't make them as default. You see? Yeah. So the first name and last name should be always given with values. The rest of them, we have defaulted them. So with the default parameters, right? You see that? So at the same time, you define the value in the data class, I can default them with default parameters. So when there's a default parameter, you don't need to pass them. If you don't want to pass that, it will be using the default value.
Yeah.
Yeah. And also, how do you know whether you're passing Jason as the first name and last name? That's when you use the name parameters, right?
Okay, yeah.
Yeah. So with these two, we have achieved the what's the problem here?
Oh, there's no R in the first parameter.
Oh man, yeah, I'm so bad at typing, Yeah, so second name is this. Have I missed last name? Oh yeah.
Yeah, that one's last name.
Yeah, that's it.
Mm.
say age is this, so that we know this is the integer we're passing for age, and this.
Right.
Even though if you don't pass it, it'll take it in the same order, but you can mess it up easily as well, because what if I'm passing this for that will go wrong, right? So that's why it's easier to name it as well, saying that which one is which. So age is always going to be that. So when I'm reading it, I know, that's age, this phone, this is address. Yeah. So build a pattern. We can achieve it with the data class in Kotlin, but see, this is the builder pattern with the data class. And when we're creating them, the builder will become handy with naming the parameters which we're creating with, and also using the default parameters to give the default values, so that they will become optional. Yeah. So we have done exactly the same. This all done with just one line, which is the data class, and we've created those with using the name parameters and made things optional, like they are doing this here, with some or some without, using the default parameters. Yeah. What do you think? So it's good, isn't it? Just one line, then. Data class.
Right. Yeah.
That's the builder pattern. Data class is using the builder pattern. Data class is the builder pattern in Kotlin.
Okay. Yeah.
Mhm.
So I understand where the modifiers come in now. So there's a data class called modifiers, and then all the different properties of width, height, alignment, color.
Yeah.
Right, okay.
Yeah. I don't know whether they are necessarily a data class or not, but they could. Underneath, if you go further down, you probably have some concrete data classes. Yeah, I was trying the other day. Let's open that. Yesterday I was building something. Oh, this is Android Studio. I'm learning Compose at the moment as well, because it's needed. We are using Compose mostly for the new screens.
Okay.
Yeah.
I did flash through it when I was at Capgemini, but I need to go through it again.
Yeah, man, it's a different way of doing it in Android, and also there's a lot behind it. We need to grasp some new concepts there,
Yeah.
Yeah. So I was building this. So you're saying, what's the scaffold? Scaffold takes a modifier. Yeah, this is the modifier you're talking about, isn't it?
Yeah, that's right.
Yeah. See there's a companion object, but it's a modifier. Yeah. Static factory. You see all that?
Right.
It's a companion object here. Yeah, but you can build it like that too. But then, yeah, but further down they might have some data classes, underneath. Yeah, but yeah. So the modifier, yeah, you can also do this. No, this is what you're saying. Dot and given the things you want. No.
Yeah.
Do with this 6dp.
Yeah.
Something like that.
And then you can add another dot to it and just keep going.
Yeah, correct. What does it take to max width? Is it's float 16 or something. Okay. Yeah, you can keep on going. Yeah. Alpha carrying on. Yeah, things like that.
Yeah.
Modifier dot, then infix function.
Then I haven't touched on then. That's a new one.
Yes. Yeah. There look some concrete classes there.
I'm only at the beginning stages anyway.
Yeah.
Where I'm just trying to build sample projects. just to get a feel.
Yeah, so right now I'm practicing this, right? Because I'm learning this as well. All I'm doing is I mean, I'm seeing a sample project in what is it called?
Google.
In Android.
Oh.
I'm just building it. So they have this. I'll show you, sorry, because it'll help you as well, Jason.
Yeah.
There's something called Now in Android, right? Everyone in the Android community, they are following it, right?
Say that again, Les, what?
There is something called Now and Android. You know, all these other people, you see them in the YouTube or not YouTube channel, right? They publish things, you know, about that, anything coming new, which goes into that Now in Android YouTube channel, right?
Right.
Look for it. I'll send you some information later as well. Yes,
okay, that'd be good.
This is what I'm building. Simple bottom bar with screens loading. Whereas my aim is to get to here. So the Now in Android is a sample project.
Okay.
Now in Android. This, yeah. See this? So they want to this type of application, but pure compose and coroutines. Yeah. See this complex tree, which you can easily build it with using compose, you know?
Yeah.
This is the bottom bar I'm just finished with. You know?
Okay.
Yeah. And then this type of list scrolling horizontally. This is something they call it as lazy row.
Yeah.
But Android, if you want to do that in the older way of doing Android using a recycler view, it's a headache, you know.
Oh my God. Man, with the adapter.
Yeah, with the adapter. So all that is becoming old. Like, I mean, a couple of months ago, that was the question everyone was asking. Recycler view adapters, you know, how do you get a good type of scrolling, and, you know, how does the recycler views work and all that? They would drill you into so tough things, you know. But then here now, I mean, all that is becoming old. Everywhere in the interviews, and you know, they're talking about compose.
Right.
Which is Google's now using, right? So this sample project showcase all of the new way of using compose. So
I'm gonna try this one.
Yes, have a look. It's a massive project, right? Look at this. It's big, man. It will take years to understand, you know, what this code is. Yeah, but I think I'm starting from ground level up, you know, so start to build each component as much as I can. Because I mean, I can't think of an idea, and why not? I mean, practice, you know, what is showcased already, you know. So my aim is to finish this as it looks. But but then when it comes to Android, I mean, building mobile apps like this is fun, man. It's complex, but at the same time, fun. You know, how are we gonna you know, transfer the data across? How are we gonna make network calls? How are we gonna parallelize things? You know, how the dependency management is handled. Hilt, they're using Hilt. You mentioned that.
Oh, it gives you the whole basics of building.
Yeah.
Okay, so you touch on everything.
Sorry, say again, please.
So I'm saying in this project, you will touch on everything from dependency injection, to view models, to network calls.
Exactly. It's a massive project. It's like another big project, you know, where we will be going and working for years. But at least, you know, it's good to start from the ground level, so that we will go through the whole journey, and, you know, we'll see what's the new standard way of doing things, you know. What is like compose in this case? How are they using compose? How are they using coroutines? And, you know, how are they using view models? How are they doing the navigation and all that, you know? Yeah, that's why it's a very good project to follow it through. Keep an eye.
I'm actually doing the code labs again that I was given in Capgemini, but because what happened was I was with the graduates and they were so fast at doing it. I was trying to compete with them and keep up, but I couldn't. So I missed a lot of it. I was skipping a lot of the valuable information to try and keep up, which was a bad idea.
Yes, true. Yeah, that's true. Because, you know, I mean, because it depends, you know, which group you're in as well, you know. So if you're with someone who has done a bit more, you know, then it's harder to catch up with them. Yeah. So in that case, my advice would be start building something by yourself, or because of this what we are doing here is not going. It's not only just going to give you the design pattern knowledge. It's going to give you the knowledge in Kotlin as well. That how I'm using things and what's the language offers you, you know.
Yeah.
That's why beg, you know, to you know, go ahead and, you know, I mean, try this by yourself. So just take a half an hour or so and try to do it by yourself, you know, like what we did today.
Yeah.
Just think of this as the requirement, and, you know, how do I design this class? How do I design my classes to do this, you know? Then that's a good practice, man. And then what I can guarantee you is if you do that, you will step up your game quickly, you know, and then interviews will become easier, not bitter anymore. And then when you start working, you can get up to speed easily as well. And you can, you know, in the reviews, you will raise good points saying, guys, you know, why don't we use a factory method here and things like that. And then people appreciate a lot, you know, then they will say, oh man, he's good, you know, because that's how we gain the name, you know, I mean, the popularity in the teams, right? Don't forget, there is a probation period as well. In any way we go, we need to perform that. But then, you know, I mean, if we do our homework, you know, then we don't need to worry about the rest of the shit, you know, I mean, the rest of the noise.
Yeah, definitely.
And everyone is learning. See, I'm learning, you are learning, Charity is learning. Well, I'm learning Compose now. Everyone is new to this new way of doing in Android, right? You know, so everybody's learning at a different time.
Yeah. So can you just tell me the the difference between functional and the Java way? Because they said Kotlin is a functional programming language.
Correct. Yes, that's a good question. So that is also an interview question, right? So in Java, it's object oriented, right? So when I say that, I can simply explain that, you know, I mean, if you want to create something in Java, you need a class. Yeah. So every basic building blocks are classes if you want to build a system. So for an example, we're building a system like this, a mobile app like this, right? In order to create a simple thing there, you know, I mean, I would think of a class. Yeah. An object like that, a picture, a profile thing, you know, then I would be immediately thinking a profile class. So that class should be, you know, handling, you know, I mean, how to get the name for this profile thing and, you know, the picture for it and, you know, what sort of actions it will have. An add button is there. So when I press on it, what action it's going to do and all of that. The functional programming in this case, it doesn't let you think like that. So it will let you think in a way what each function will do. So the function in this case, whereas in Java, if you want to compare it, the methods you will write in the class. So this is more functional. So that means you will write the function to do certain thing. So the in this case, I'm breaking myself even down. I'm thinking as, you know, what is the function I would need to do this thing. The first function I can immediately think of as, I mean, I need a function to display the name here. Yeah. So if I break the functions down and break that out as the concrete or the, you know, the what is it called? The very flat, as in, I mean, what's the building block of it? Before we said the building block is a class. So if you build a class here, that class will be the class to show the profile. But then I don't have another class to display names, but the display name will stay inside this class to call it to get it, right? So if I want to display name, I'll need to call the class, the profile. Yeah. But if I ever want to display name somewhere else, maybe in another place, somewhere here though, I can't have it because of it's very coupled with the class itself. So they broke it down into functions. So simple building blocks are functions. Display name will be a function outside living anywhere, and then I can call it. So that's why they say Kotlin is also a functional language, because here you see, as we have done this, I didn't need a class for this. I didn't create a class at all, but I've defined the functions. You see. Yeah, all I need is just a function to do something with something, which is to create the object. But in Java you can't do this. You know, you have to have a class to create your methods. It's more object oriented in that case, in that sense, you know, because of you need to have the classes which to create the objects. So it's object oriented. But here is functions, you know, just all building blocks are just functions, pure functions, inputs and outputs. What does it give you for the given stuff in for the inputs?
Inputs and outputs. Is that that is the fundamental thinking behind functional.
Correct. Yeah.
Okay.
You know, but it's a mixture of functional and object-oriented programming. Kotlin is, because I can have classes as well. If I want to push this into a class, I can create a class. Nobody's saying you can't. So it has the it has the object-oriented features plus the functional features. There are some other languages which are pure functional. You can't even have a class inside it, which is something like Arrow, or Scar, or Closure, and things like that. Those languages are pure functional.
Okay. I heard of the name Closure. Is that what they call? Like, I've seen it in writing Kotlin code, and then it says if I hover over a lambda, it says something about a closure.
Yes, correct. Lambda is a closure. But Closure, there's another one which is purely a functional language, like lambdas. Everything is a lambda or a function, Or Arrow is also popular. Is pure functional language.
Never heard of this one. Arrow.
Arrow is also Arrow. Some of the features Kotlin uses is coming from Arrow.
Is that something to do with Dart?
No, Dart is for Flutter.
Okay.
Yes, Dart is used in Flutter, which is similar to Kotlin. Yeah, that is a similar language like Kotlin.
Okay.
Yeah.
So, sorry to take you off the subject.
No. That's all. That's why we're here, right? I mean, we want to talk about anything. And
So the functioning. It was the thinking. They were saying, "Oh, you got to think in a functional way." I didn't really understand what they meant by thinking a functional way, but you've just broken it down. It's basically using functions to create all your how can I put it? Objects. Is that right?
All your all kind of the requirements, So the function will be the building blocks,
So it says declare. It's a declarative language. So
correct. Yes, because it tells more.
Those words are a little bit like, when you use those words, it doesn't really make sense to someone like me. Like when they say,
first time. Because hearing it for the first time. Declarative means, it tells you what to do rather than how to do it. In Java, look at this for an example, right? Here, it's a lot of how to do things going on, right? The builder pattern in this case. You see, in order to achieve the builder pattern, we need to write all this to say, how are we going to get this working? But here, it's just, this is imperative way of doing it, because of it's talking a lot of hows. How do I have a setter? No, in order to do this, how do I do this? I need to have a setter. I need to have build a class and this and that. But in Kotlin, it's very declarative, because it just worries about what to do. I need a class. That's all I have to do. That's all I need. So it tells what to do. That means what am I doing here? Creating users. So just use the data class and pass in the things you want. So first instance, what to do is just to pass in all of them we want. Second instance, we want to pass in what to do is just pass in the first two, which are mandatory, and one optional one. So we are caring more of, what's the problem rather than how to achieve it.